Hello Group 2. In this video, I will give you some targeted feedback for your project based on the draft that Rhonda had sent me. So I'll go through section by section. The main questions were what to do with some of the conditions that didn't meet and how to proceed with the hypothesis testing. So the first mention that I want to make is about the data collection. I would like to see a little bit more information about where the data was collected, how it was collected, and anything else about this data that makes it specific. So was it all from Catawba County residents or surrounding counties? When I read the information, I'm assuming that this is a clinic where people come in and they're reporting flu symptoms, therefore they get a flu test. Then, when they're getting that flu test, we're also recording whether or not they had the flu vaccine earlier in the season or not. So maybe explain a little bit more, and then we also want to think about if we did have to get more data, you would want to get data that was collected in a similar manner. So I'll talk a little bit more about that later. Notice once we have the information, we're assessing whether or not they had the flu, but then also the flu vaccine or no flu vaccine earlier in the season is the factor that divides us into two groups. So one thing that I wanted to note with the verbiage is you're not exactly doing an experiment. And in fact, you mention a cross-sectional study. It's kind of almost a mix between cross-sectional and case control. You are getting people at one point in time, but then you're looking back whether they had the flu vaccine or not. I agree that it's best classified as cross-sectional because you're not selecting participants based on whether they had the flu or not. So I agree that you are doing a cross-sectional study and then dividing them up based on their prior history. But you don't really want to think about group 1 and group 2 as experimental and control because you didn't give one group the flu vaccine and expose them to the flu, not give the flu vaccine to the other group and expose them to the flu. That would be a true experiment. Whereas this is more an observational study. You don't really know if the percent who had the flu vaccine who might have had flu symptoms who didn't even come in, right? Or who didn't get the vaccine who had flu symptoms that didn't come in. There's sort of this part that's not very well controlled here. So I would kind of scrap some of that verbiage and then think about more using the language for observational studies. However, the verification of the requirements is exactly what you want to do in these few steps. Here, I agree that the sample size is less than 5% of the population, but you want to target or say a little bit more about who the population is. Again, this goes back to how the data was collected. Are you thinking about Catawba County residents who received the flu shot and did not? Certainly you should be under that 5%, but explain a little more here. Then, really the problem came with this part. The 25 was the number who received the flu vaccine, and the 12% was the percentage who tested positive for the flu once they had had the vaccine. So notice when you do the n times p times 1 minus p, that number is less than 10, which is noted. And this causes problems with the confidence interval and the hypothesis testing. Whereas for the other group, there's no issue, but it's not too far above 10, meaning that 77 was probably one of these smaller sizes that you could use for this group and be able to proceed. So let's go on down, look at our charts and graphs, and then we'll get back into the conditions that weren't met and how that impacts your hypothesis testing and what you can do. So going down, we've got some pie charts. I would recommend writing a little bit more about comparing those, maybe even making them smaller, putting them side by side, just to make it easier to look at. Now, when we get down here for the confidence intervals, let's see, I think I scrolled too far there. For the confidence intervals, it looks like there was a confidence interval created for the difference. When you're doing two groups and two proportions, it's often helpful to create two separate confidence intervals. In other words, a range of people that we would predict would get the flu if you didn't get the vaccine, and a range that would predict the percentage you get the flu when you did. In other words, it's easier to interpret two confidence intervals a lot of times than one, meaning you can use two separate, like do the procedure in Chapter 9 twice, one for each group. However, since we didn't have the conditions meet for Group 1, you can't really use the confidence interval procedure in Chapter 9 for Group 1. That also means that you can't really use the confidence interval procedure for the difference here. In other words, this confidence interval doesn't actually hold much weight because the condition for Group 1 didn't work. But on the flip side, you can demonstrate that you know how to create a confidence interval just with Group 2, where the conditions did meet. So that's what I would recommend first of all. If you didn't collect any more data from this or for this project, then you could still do a confidence interval with Group 2 and compare the percent in Group 1 even though you didn't have a confidence interval. There's also a little bit of problems with the interpretation here, but I think that would be fixed if you had two different confidence intervals. Now, let's look at this hypothesis test. The hypothesis stated here, the null, the two populations are equal, the percent to get the flu, and that the percentage is less in Group 1 than Group 2. Now, again, the conditions here are going to be similar. You can't run a two proportion test if you don't have the n times p times 1 minus p is greater than or equal to 10 for each group. So what that means is I would recommend going back and thinking about whether you have access to more data. If you have similar data from another day at the clinic or another clinic that collected very similar data within the same time period, that would be an option. But if you don't, you can't use this formal hypothesis procedure. You might be able to informally compare and say, it looks like this might be true, but we would really need more data for our results to have statistical significance. In other words, you can't get a valid p-value when your conditions don't check. However, there are some things we can do with small sample size. The problem was really population 1. So here's a couple thoughts that I had on how to address that. If you had some national data, maybe from Googling or reading in different journals or different things the CDC puts out on the percentage of people who receive the flu vaccine and still get the flu, you could compare your Group 1 to that. In other words, for some reason, if you were able to find, I'm just going to make up a number here, that 20% of people who received the vaccine got the flu, or that under similar conditions, people who came in and tested positive for the flu and then they had the vaccine, the similar comparison to what you did was a 20% number. Again, the phrasing on this is a little bit tricky because you're looking at people who presented with flu symptoms and tested positive for the flu. So if that number you could find somewhere were something like 20%, you could compare your Group 1 to a national average. Again, it doesn't compare flu versus not, and I think that's a good thing to do informally in your project. But for the actual hypothesis test, you could compare this percentage to a national percentage or to a Catawba County percentage. Now, you do have to be a little bit careful because you can't use the one proportion test using the normal curve, which is the standard procedure in StatCrunch, like this part. What you have to do is go through the binomial distribution for the small sample size to actually get your p-value. The book has some examples of that, and I can certainly help you out. So you get a p-value from a different method, still using StatCrunch, but using the binomial. So that's an option, but what you would have to do is do some research to see if you could find a comparable national or state average for similar circumstances. Again, that's going to require a little bit of looking. You could probably find those numbers. So what I would propose that you do is use your Group 2 to create a confidence interval, compare your proportion from Group 1 to that informally, therefore demonstrating that you can create confidence intervals. Then see if you can find another number to use to compare Group 1 to run a hypothesis test using small samples. You could also look for something similar with Group 2, and that might be a good strategy as well. If you can't find a national percentage I was talking about with group 1, if you found something with group 2, then you do have the conditions check if you were comparing that proportion that group 2 targets to a national average. In other words, do some thinking here. The calculation of a p-value, if you're looking at comparing group 1's value to the bigger group, you have to have you would have to have the condition meet to use the normal curve, and if it doesn't, you use the binomial. Whereas group 2, if you found a national percentage to compare it to, you have that condition check, so you wouldn't have to use the binomial or the small sample size. All right, so that's probably enough for you guys to think about. I'm sure you will have questions after this. Think about my comments, particularly the hypothesis testing and how to proceed, and we can go from there. Hold on, thought of one more thing here, pop back into the video. If you did find more data that you could use and compare with, like from another clinic, I do want to note on the conditions, sometimes groups mention the n equals 30, whereas you want to be careful that you don't confuse the 30 with the n times p times 1 minus p. In this case, even if you had 30 in your sample, the 30 wouldn't be enough for that n times p times 1 minus p to check. The 30 really has to do with when you're testing for averages and not proportions. You would probably have to get closer to 75, probably at least 50, 75, similar to kind of the number you had here. Notice that that one barely checks, but you would probably have to at least double the amount of data that you collected for that group 1 for this to run. So I just wanted to note that as well. Don't get hung up on the 30, and in fact, if you were to just sample people on the street, they don't really have the same conditions as were met in the clinic. In other words, they're not presenting with flu symptoms and then getting a flu test. So you really would have to go back and find similar data to match up and be able to find enough to be able to make this condition work. All right, I think that's it. Send me your questions and we will go from there.